All right, hey everybody, how's your Ignite? Yeah, having a good time? Excellent. So listen, we got a ton of stuff to talk to you about Windows Server. Man, Windows Server 2016, it is an amazing release. I'm reminded of a Woody Allen joke. He said he took a speed reading course. Last night he read War and Peace in 20 minutes. It's about Russia, he said. Anyway, there's so much about Windows Server 2016. We have a small amount of time, and we're going to go fast, so pay attention. Today, we're going to focus in on the application, writing applications for Windows Server 2016. On Thursday, we'll be talking about Windows applications, sort of the operations side, the DevOps side of Windows Server 2016. I'm Jeffrey Snover. I'm a technical fellow and the chief architect. And joining me?
I'm Jeff Woolsey. I'm a principal program manager in Windows Server. It's a pleasure to be here. Thank you guys very much. We have a lot of things to get to, and I'm going to dive right in. If you think we're going to pause it for anything here, it's not happening. We got to get going. Ton of content. I want to start right off the bat with the voice of the customer. I wanted you guys to, one of the things I always find it's interesting to let you guys know what we're hearing from your colleagues, from other people about when they come talk to us about what their concerns are. One, there are too many stories about companies getting hacked and not knowing about it for months. It's clear that security is top of mind for everyone, and it doesn't matter what part of the stack you live in, whether you're in infrastructure, whether you're in app, doesn't matter, whether you're in operations, everybody's thinking about this. How can we get the benefits of public cloud in our data centers? Public cloud is definitely changing the way we think about application delivery in terms of the application model and speed. I'm worried about building the wrong thing. We spent years building virtualized data centers that don't look like any cloud. Yes, people are realizing that as they start to look at their data center and they look at how we're doing things in Azure or even how the other guys, AWS is doing it, for example, they don't look similar. One just very fundamental difference. In the public cloud, we don't use SANs. Everything's software-defined storage. We use software-defined networking. We use software-defined compute. That's just the infrastructure layer. At the application layer, we don't build monolithic apps. We think about apps in very modular, very microservice-oriented ways, and we'll get very much into that. So when I ask people very clearly, where do you guys want to be in 3 to 5 years? Where do you want to be strategically? Don't tell me about what you're doing now or what you want to be doing in 6 months. Where do you want to be in 5 years, 3 years, 10 years? Where's your company going? Uniformly, the answer is all the same. Hybrid cloud is our strategic direction. We're all in. I love the last one's my favorite. Hybrid, of course. Seriously, is there another answer? I'll never forget it. And it was like I was talking with the customer. He's like, no, wait a minute. Jeff, really? Is this a trick question? I'm like, no, I'm just asking. I want to know. He's like, yeah, there's literally nowhere else we see that makes sense for us. We absolutely want the best of both worlds. And we think about that not only from the infrastructure layer, but from the applications, the monitoring, and all parts of the stack in an enterprise. So what they keep telling us is, we love your vision. We desire exactly what you talk about. Because when we talk about cloud at Microsoft, we are very clear. It's not virtualization. And I love hypervisors. I've been working on them for a very, very long time, and I'm the first one to tell you that's not the end story. Customers don't come in and ask, Jeff, tell me about your hypervisor anymore. They tell me, no, how do we get to cloud? I want hybrid cloud so bad I can taste it. I want to be able to do stuff on premises because there's some stuff that no matter what anybody says, we're going to keep on premises because it's that critical to our business. Okay, fine. We're not going to tell you where or how you should run your infrastructure. If you want to run cloud on premises, great. But at the same time, they're telling me, I very much want to take advantage of what's happening in the public cloud. I want to take advantage of security. I want to take advantage of identity. I want to take advantage of scale. I want to take advantage of agility. And also, when I write my applications, I want them to be able to run in both places. I should be able to deploy them on premises and deploy them in the public. And if I need to bring them back, I can do that as well. So again, this covers all parts of the stack. Windows Server. Very much the foundation of our cloud. I have to remind people of this quite often. Certainly, everybody knows that it's part of your on-premises data center. Okay, you run Windows Server on your hardware, you run Hyper-V, you're running it in your virtual machines. But let's not forget, it's also the basis of Azure, and it's the basis of Azure Stack. Let me be super clear here. Azure runs on Windows Server, period, end of story. And the beautiful thing about that is, it's the same Windows Server bits we sell you. Azure today runs Windows Server 2012 R2 Core, and they're in the process of moving to 2016. They're thrilled out of their minds because there's a whole bunch of new capabilities that have gone in there specifically because of their requests. And guess what? It means you're getting them as well. So even if you told me today, Jeff, I'm not using Azure today, I'm on the roadmap to doing it, but I'm not using it right now, but I'm going to deploy 2016, spoiler alert, you're actually getting the benefit of our public cloud already because you're getting a bunch of those features courtesy of Azure in on-premises as well. So the cloud is very much changing expectations. It's about hyperscale, it's about availability, and it's about agility. And I can't underline agility enough. I remember a few years ago when people were still asking why cloud. I remember that was the first question. And I think as an industry, when we don't know the answer, we say because it's cheaper, because we just default to that. Actually, that is not why people are moving to cloud. It's a component of it. That's not the reason. The reason why they're moving is agility. It's fast. If I need a Hadoop cluster, I can buy a whole bunch of computers, I can buy a bunch of storage, I can buy a bunch of networking, I can configure this all and get that software going, and maybe I'll have that working in a few weeks, months. Or I can go up to Azure and click, it's there, it's ready to go. If I want multi-factor authentication, yeah, you go up in Azure, it's right there. At the same time, we want to deliver more and more of these services on premises. So for example, anybody watch the Rio Olympics? Pretty super popular. It was all delivered on Azure. This is actually the second or third time we've delivered the Olympics off of Azure. All of that was delivered through our software-defined networking stack. All of that was delivered through our solutions running on Azure, and guess what? Globally expanding and dynamically expanding around the world. And I don't have the numbers memorized off the top of my head, but I can tell you we set world records for live streaming everywhere, for everything. And we delivered at a better quality than ever. Sochi was 720p. Rio, full 1080p everywhere. So, that's hyperscale, that agility, it's very much changing how people are thinking about their expectations for application delivery. Certainly you have monolithic apps, yes, that's how we've done it in the long ago world. But as we've moved and we started to break things apart, we've started to realize, well, breaking things apart into tiers was good, but if we can break them apart further into microservices, we can get further advantages that cloud can really drill in on. And of course, yes, you've got folks that still every so often tell me, yeah, we've got a few physical machines, but for the most part, everybody delivers everything new on a virtual machine. But now we have the rise of containers, which is very interesting. It's clear to me that still people are trying to figure out what these things are. I always ask people kind of what are their thoughts, and I generally get people telling me, oh, we hear those are going to kill VMs, or I get people telling me that VMs are going to kill containers, and I'm like, no, they're different. It's like comparing an Apple and a Buick. They're just totally two different things. So they can work great separately or together, and we'll definitely have some demos. I'm excited for you guys to see some demos on containers, and we'll drill more into these app expectations. Of course, Azure Service Fabric and functions, we'll get more into that as we get going. Finally, tensions drive change. And if you're a sysadmin, if you're in the IT pro side of the world, we feel you big time because you're in the middle of this. On the one hand, you're being told by your bosses, by your business, you know what, I need you to go faster. You need to be delivering more. It's not just, it's not just the ability to fire up a VM and call it a day. It's about delivering services that your developers will use to be successful. At the same time, you're also being told, well, it can't ever go down. You've got to be super, super stable. You've got to be rock stable. You've got to be predictable. Any downtime is unacceptable. And somewhere in the middle, the developers are screaming, and we want this yesterday. We want this faster, 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 faster. Well, cloud service delivery is very much in that middle world. Is how we think about, well, how can we help you deliver services faster to your infrastructure and to your organization? That's why we're so focused on things like Azure Stack. It's why we're so focused on delivering more Azure value in Windows Server, so you can bring more of these benefits to your organization. So with that, I'm going to pass it on over to Jeffrey.
Great. So first, let's talk about microservices, right? Microservices are all the rage. So what's going on with microservices? To me, the heart of microservices is environmental decoupling, right? In the past, we take lots of different components of a system, and we put them all in the same environment, and often integrate them with DLLs. To me, microservices is about breaking the DLL contract and turning it into a protocol contract. Now these components talking through protocols means that they can exist on different systems. Existing on different systems means that those different systems can have their own life cycle. And in particular, one system can update, the DLLs that they use and not affect the other system. Anyone ever got burned by that MSV CRT 41? Like everyone. Worst thing in the world. Well, again, why was that? And the answer was two components had a dependency on a DLL, and one of them upgraded the new version, and it broke the other one. If those two components were in their own environment and had their own copy of the DLL, somebody could update it whenever they want, the other person doesn't get affected. Additionally, because you talk through protocols, it means, I can put a software load balancer or a load balancer in front of that thing. Instead of having one, I can have 2, 3, 4, 400 and scale out. It allows the two different teams to work much faster and at their own pace. So to me, that's sort of the heart of microservices, okay? By the way, so take a look at the slide here versus the slide here. Can you tell which one the engineer wrote versus the marketing guys? Okay, anyway, so here you go. So microservices are awesome. They really are. They're the future. If you're starting a new project, you definitely want to go down the microservices path. No doubt about it. But everybody's dealing with their existing stuff. Most of us already have an application, and that application is not built as a set of microservices, right? So the answer is we need both. And here's where containers can help, right? Containers can give us some of the benefits and allow us to go faster. And going faster allows us to free up some time so that we can go back and step by step start to refactor things. Look, if you have one big glop, turn it into two big glops, or one big glop and a small glop. And then from there, step by step by step, you want to break things apart. And again, containers can be very helpful in doing this. So this is sort of the microservices stack that we're sort of optimizing for, right? You got Microsoft Azure and Azure Stack. We talk to things through the Azure Resource Manager, leveraging Windows Server, and then you can run those in virtual machines, you can run them in containers, and then there's a variety of container management systems. The one we're optimizing for and investing heavily in is something called Azure Service Fabric.
So as we think about application innovation in Windows Server 2016, we really think about three big major buckets behind this. Because one of the things we want to make sure is we want to give you a very prescriptive path, which is as we start to move to new types of application models, we want to make sure you understand, hey, there's a path for those legacy apps or those line of business applications that are still important. Is there a way we can modernize those? Can we also take existing apps and run them with better security? Everybody wants that. And can we also, when we start to build new applications, can we go and create innovative new cloud apps from the get-go? So let's start with looking at all of the existing apps first. So the left-hand side, you've got Secure Fabric for existing VMs. That's very much IT Pro focused. So if you have existing VMs, we want to make sure that we give you the best, most secure fabric, and we actually want the operating system to play an active role in your security posture. So there's some things that we can do there that just by literally moving an application into 2016 is already going to help you secure your applications without doing anything additional. Then you start to move to the model of, okay, what if we took our existing legacy or line of business application and just containerized it? Because by doing that, we're going to start to get the benefits of both. You're going to get some IT benefits, but your developers are going to be happy because it's going to allow them to start using some DevOps practices. It means they're going to be able to start using containers, being able to deploy faster. For IT Pro, it makes life a lot easier when you're talking about deploying applications and servicing and lifecycle. And then finally, as we start to talk about new apps, yes, that's when we start talking about cloud-created apps, cloud-native apps. And this is where you start getting developer focused. This is when they start really thinking about, okay, what is the architecture I want to use? How am I actually building this thing instead of traditional monolithic microservices? And what are the things I want to do to integrate with PaaS and SaaS services, both on-premises and in the public? So let's start with the very first one. Run existing apps with more security. Now, there's a ton of security talks. I've got a session after this one where I'm going to dive pretty deep into security. But for this one, I just wanted to point out a couple of things for your existing applications today. And again, we're taking our investments in our public cloud and also helping you on premises, again, through things like our cyber crimes unit. Security should be a top priority for everybody in IT. I know some people say, oh, no, I was actually talking with a guy at the booth yesterday. He was in IT, and he was telling me about security. And I said, well, tell me about security. He said, I don't have to. I have a security team that does that. I'm like, oh, no. You all should be thinking about security, okay? That's everybody's job now. And the reason why is it's gone from casual hacking to, come on, it's a daily basis now. And these hacks aren't little. These are massive. These are huge. HIPAA breaches, Army National Guard, somebody, we had a breach of, like 500 million email addresses last week. So this is very much top of mind, and it's almost becoming regular. And the thing I worry about, it's becoming regular that people are getting numb to it. You shouldn't be numb, you should be getting outraged, and you should be getting on top of this, and let's help you secure your infrastructure so you're not one of these statistics. Because that's certainly not going to look good on your resume. One perfect example, if there's any organization in the United States government that I would think would have a rock-solid, airtight security posture, would be this little organization called the FDIC. They only do something, like manage our economy. Well, they were hacked between 2010 and 2013, and we just found out about it. If that isn't a wake-up call, I don't know what is. I mean, it's like, come on, people. And very often these organizations will come talk to us, and we'll talk to them about security and talk to them why they should be leveraging some of the best practices and techniques offered. And very often they come to us like, yeah, we know how to run our stuff better. And I see stuff like this, and it just makes me shake my head. And like, please, we're all in this together. In addition, cybersecurity is not only IT, but it's now a CEO issue. With the average cost of $4 million for the data breach, look, CEOs are now their heads are on the line as well. It's not the director of IT's problem anymore. It's making sure that the CEO is actually paying attention and that you do have policies in place. And the average corporate liability is $500 million. So this is not chump change. This is real dollars at stake here. In Server 2016, we very much focused on security as a core pillar. We always focus on security, but one of the biggest differences in this release is we said, you know what, we've done so much, we're not going to just weave this into our storage talks or our network talks or our AD talks. No, we did so much here, and there's so much concerted effort around security, we said, no, this is absolutely its own pillar. Because every customer we talk to about hybrid cloud or app development says, what are you doing to help me protect my infrastructure? What are the security things you've done in place? So I'm only going to point out a few of these. If you saw Jason Zander's keynote yesterday, you saw me demonstrate shielded VMs. I can tell you, I literally walked off the stage and pretty much got tackled by a few people. One guy direct from a healthcare company said, oh my gosh, we need this now. And shielded VMs, quite simply, to put a fine tooth on it, is if I have a virtual machine and it can only run on this fabric, and I take this virtual machine, even as a full admin, and try and run it elsewhere, it doesn't run. It's an encrypted blob. And I will talk about this a ton more in my next session, but quite literally, nobody in the industry has this. And I can tell you, I've talked to governments, military, healthcare, financial, Wall Street, you name it, and they are like, oh my gosh, this is manna from heaven. We will take it. Shielded VMs is huge. We have a ton of sessions on it this week. Nano, we're going to talk about a lot more. We'll get to that a little bit later. And then, of course, containers, we've done a tremendous amount of work, not only adopting containers, but actually advancing the state of the art on them as well. Because open source, in the Linux world, they have containers. But what we found was some interesting things, like people would take a container and then put it in a VM, and it was the only thing running in a VM, and you're like, wait a minute, what was the benefit of doing this in the first place? So we said, what if we actually married virtualization and containers and created a Hyper-V container that gave me all the benefits of containers with enterprise isolation? Ding, 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 we have a winner. If you're developing applications, the important thing to know is you just write your container. It's the same exact process. But at runtime is when you determine, is it a Windows Server container or a Hyper-V container? The important thing for a developer to understand is it's exactly the same, and it plugs into your Docker tools. You get a demo in just a minute. Finally, one last thing is threat detection and threat resistance. For the first time ever, Server, we just put anti-malware in the box. We've had this shipping in client for some time, and we've always said if you need it, you can use third-party integration. But we've reached the point now that anybody deploying a server, almost 99 times out of 100, needs to check some compliance or regulatory checkmark that says, I have anti-malware. And so we said, you know what? We're putting it in the box. If you still want to run your third party, you can do that. But you know what? We're going to make it super simple, because now we don't know where you're deploying your virtual machine. Is it in your secure enterprise, or is it in a public cloud where you don't know who the actors are in that location? So we said, you know what? We want to make the OS an active participant. We've also enhanced it through a number of other things like control flow guard, code integrity, and so much more. And again, ton of security sessions. We'll drill into this further. But I want to keep going because we want to be very focused on the app side. Last thing I want to point out is from a security standpoint, if you're looking for steps that you can take immediately, this is available publicly. This is right there on TechNet. One of the things we're trying to do is actually help protect admins. Okay? We all shake our heads when we say, of course you would never browse the internet on a server with a web browser. Of course you'd never do that. And then guess what? They do. As full admin, for crying out loud. What's the matter with you people? It happens way too often. So you know what? We put in a whole bunch of things to help protect, give admins better control, and actually only elevate their privilege when they need it through just-in-time administration. So we've done a whole bunch of things to actually provide role-based access control, time-based access control to admins, and we actually have an easy process that you can go through to help protect your organization. Love what we're doing here. So we want to evolve existing applications with new technologies. Well, containers are on this path that helps us getting to DevOps. So, containers. Real quick story. When you talked about containers, there's a lot of FUD and a lot of confusion. I usually give a very quick scenario. Here's what it is. I'm Jeff, I'm a developer, I'm writing an application. It's got an executable, it's got libraries, and it compiles perfectly on my laptop every morning. It is literally perfection. I'm gonna get a raise and the company's gonna do great. I'm now giving it to IT, and IT to deploy it. IT, please deploy it. IT says, oh, fantastic, no problem. Let me run the installer, let me follow all your instructions, great, this looks great. I go to run it, doesn't work. Doesn't work. I send an email to developer, he says, that's really funny because it works every single day on my laptop perfectly. Just read directions again, if you have a problem, send me a log. Okay, no problem, I'll try and run it again. Doesn't work. Here's the log files. I don't see any problems, my code looks perfect. I'm now sending an email to his boss because I'm angry. Because I should be getting a raise right now because this application is so perfect. All this boss hears is, I have an angry developer. And he tells IT, do whatever you need to do to make him happy. Do whatever you need to do. So he says, hey, what can I do? And the developer says, let me log into your server as admin and see what's going on. Now at this point, IT knows this is a really bad idea. This is the last thing on earth I want to do. But boss told me to make him happy. So what happens? Developer logs in and goes, oh, you need this framework. Oh, you need this patch. Let me run this script. Oh, yeah, there's some other things I need to put. Oh, you're missing the latest version of this framework. Okay, now we're good. Now, see, it runs perfectly. I told you, just like I told you. Now IT's looking at this going, I have no idea what this is. It looks like nothing in my infrastructure. I don't know what he put on here. How do I patch this? How do I back this thing up? What's the deal with this? So now you know what happens? He sticks it in the corner and says, we're just going to leave it there. And that's how you end up with that server 10 years later. You go, I don't know what that thing is. A lot of people are shaking their heads in the audience. Here's what containers do. Now, I'm a developer. I'm Jeff. I'm writing my application, my executables, libraries, frameworks. It is perfection. It is awesome. It is spectacular. I'm going to get a massive rage. I then package it up in a container. And I give that container to IT. IT doesn't run an installer. IT says, run container. Just works. That's it. Developer, 10 minutes later, realized, whoops, I left a stupid bug in there. Here, hold on 1 second. Let me give you a new container. 10 minutes later, IT says, OK, let me turn off the container. No one install, nothing corrupted, nothing in my registry, none of that. Nope, just turn it off, put it in the library, get the new one, turn it on. It just works. Containers make it that easy and that fast to deliver new applications. And so now dev and ops can work faster and better and closer together to deliver more value to your company. That's what it's about. So introducing containers for Windows Server. Very quickly, When you think about containers, containers is actually a type of virtualization. It's really operating system virtualization, which is very different with what we've been doing with VMs. With VMs, we actually virtualize hardware. We pretend to be hardware so you can install an operating system, you can install your apps, and it looks like it's running on hardware. That's what a VM does. And every one of them is completely isolated. Every VM and can run a different operating system. Windows 7, Windows 8, Windows 2012 R2, Red Hat Linux, SUSE Linux, Debian, Ubuntu, and it all just runs and they're all completely isolated and everything's good. In the container world, and by the way, this is basically true for Linux containers and Windows containers, what happens is you're actually virtualizing kernel mode. So what happens is you have an application that you install, and it's actually talking to the kernel. And every time you install a new container, it's talking to the same shared kernel. Now, benefits, it's super fast. There's no virtualization involved. The thing is, each one of these is isolated from each other. They have their own view of the file system. They have their own view of the registry. They don't see each other, but they're talking to the shared kernel. They're doing it very, very quickly. Okay? Now, this is both good and bad. On the good side, it's really fast. On the bad side, if you're doing compliance and regulatory, and you tell them, by the way, I need to pass a regulatory and compliance, and you say the words shared kernel, they will run screaming out of the room. I've talked to the guys who do compliance and regulatory. I said, hey, containers are the new hot thing. What do you think of these? They said, yeah, we hate those. I said, what? Everybody's talking about these. Yeah, we hate those. Shared kernel, the two words we never want to hear together. So rather than argue with them, we said, you know what? We're going to create two types of containers. We're going to create a Windows Server container, which is analogous to what's going on in the Linux and the open source world. And we're going to create something called a Hyper-V container. From a development standpoint, again, they look exactly the same. But when I deploy a Hyper-V container, it basically says, oh, by the way, you're going to speak to your own kernel. There is no shared kernel. And I'm going to put up Hyper-V isolation. So you get enterprise isolation. You can also service the kernel on a different schedule than the underlying OS because it has its own isolated kernel. And by the way, if you're running in a multi-tenant public cloud, that's absolutely what you want to do because you don't know who the other actors are on the server. So enough of me talking. Let me actually introduce Patrick Lang, who's a program manager for containers. Let's give him a round of applause, everybody.
All right, thank you so much, Jeff.
Thank you, Patrick.
All right, so right now I'm going to go ahead and put on my developer hat. I don't have it with me, but pretend it's there. So I'm a developer. Where am I going to start developing my app? Well, I've got a laptop here, and it's running Windows 10. One of the things Jeff just mentioned is that Hyper-V containers run their own kernel. So that means that if I want to develop containers that are targeting a new platform like NanoServer, since Hyper-V is built into Windows 10, I can actually run a Hyper-V container there. So first, let's look at the code that I have available here. So I've got a simple .NET MVC app that's built using .NET Core. And we've got a number of different files here. So let me go ahead and just get that built real quick. .NET publish-o .container build. So what this is doing right now is it's actually building my project and packing up all the files that are needed in one place where I can conveniently pick them back up. But instead of deploying to my local machine, I'm going to use something called a Docker file to actually build a container. So what I'm doing in this Docker file is I'm starting from a NanoServer image that's already configured with the .NET Core framework installed. I'm adding my code into it, and then I'm saying, here's the command to run. All right? So now that my code is built, the next thing to do is actually build the container. So I'll do Docker build. I'll go ahead and mark this one as version 3. So with this one command, Docker build, what it's actually doing is it's packaging up all the files that I want in the container right now, and it's shipping them off to the Docker management engine. And right now, behind the scenes, this is actually bringing up a fresh, completely clean container, putting all the files that I specified in there, doing all the configuration tweaks that I could have been doing by hand, just 10, 15 years ago when I started in IT. I had to do all this stuff by hand. But now it's all scripted, and it's being packaged up into a container that can be very rapidly deployed. So give us just a few more seconds there. All right, so we successfully built a container here. So that's all fine. So now let's talk about deploying it. So as Jeff mentioned, it only takes one command, Docker run, to actually go ahead and deploy a container. So I'll go ahead and just deploy this on my local machine. So right now, we've got some great magic going on in the background. The Docker engine that was running on my laptop actually spun up a Hyper-V container, and before I even finished this sentence, it was already up and running NanoServer, and my application is running. So next I need to just quickly grab the IP for that. Ooh, pi. Okay, so I've got the IP address of the container I just deployed. I didn't have to configure any VMs, didn't have to do anything like that. All I did was say Docker run. And then if we go back over here to this window, which is showing the console output that would be running in that's running in the container, we see it received a request, it responded, and I've got a web page. It's responded requests, it's up and running, it's fast. So this is a completely clean NanoServer container that I was able to bring up in just a few seconds to run my application. So, okay, it works on my machine. It's extremely fast, that's great. But now that I've got it running on my machine, what I actually want to do is be able to share this with the world and roll it out in production. So the next command after there, now that I've built that, is I can go ahead and do a Docker push. And what this is doing is this is actually uploading it to the Docker public registry that's called Docker Hub. So anybody in the world could go and download and deploy this with just one command, Docker run, just like I did up here earlier. And so let me actually grab that command. Okay, so same command here. Well, almost. And now what I'm going to do is I want to actually deploy this in production. So I'm going to go over to another window here where I've got a PowerShell remoting session that's open to another NanoServer instance.
So at this point, you're on another server.
Yes. Okay. So I forgot to put my ops hat on here. So now I'm the operations guy, and my dev said, hey, can you go ahead and deploy this? And you say, how? Well, just go do a Docker run. Get my image name back here.
It's IT.
Yeah, I don't need the IT, actually.
Okay.
And I want to go ahead and forward port 80 to this container because it's a live site. And with just this one command, Docker run, looks like I got a minor rendering error there. It's actually downloading this application from the public Docker Hub right now. So this server had no prerequisites installed, nothing, except Docker itself.
So just to be clear, they could all be doing this on their desktop right now.
Yeah. You could be doing this if you have NanoServer deployed. You could be doing it if you have Windows 10 deployed, because we'll automatically pull down the NanoServer image and all the dependencies here for this image. And, oh, there we go, application started. So now, last thing I need to do is figure out, well, what's the address of that NanoServer?
If you haven't seen it before, this is the NanoServer login screen.
Yeah. So we'll be talking more about that in a bit.
Yes.
Okay, so I've got 10.5.36.159. Oops, let me go back to my web browser.
And did you want the port?
Nope.
Nope.
I forwarded that to port 80, so right now it's on the live site. So now I have a NanoServer in my data center in production, and my site's up and running with just one command in a few seconds to get it started. Much, much faster than anything I've done it before. So thank you.
That's awesome. Thank you, Patrick.
Thank you, Patrick. When you saw him do Docker run, think of that as he just double-clicked on an MSI. Except guess what? It didn't spew stuff all over the registry. I don't have to deal with an uninstaller anymore. It's literally run the image, turn it off, get a new one, run it, move right along. Very, very awesome. Thank you, Patrick. By the way, while he was doing that, I didn't say this, but I want to point out, he was using Visual Studio Code. Let's not forget, this is a free tool. And it runs on Mac, Windows, and Linux. And it's got, as you saw, Dockerfile, Docker Compose integrations in there. It's integration with Docker's in there. In fact, this is getting so much traction. Google tells everybody, use this. This is a fantastic editor. It's super, super lightweight. You know, for those guys that are used to the old school VI, Vims, Emacs, all that stuff, a lot of people are looking at this going, oh my gosh, this is a great text editor. It comes with IntelliSense and Docker integration. Make sure you're checking that out. Of course, if you're someone who uses full Visual Studio 2015, yes, Docker supports all in there as well. We're very much making a big investment, and I'm sure you saw the big news yesterday that we're continuing and extending our great relationship with Docker. And in fact, the Docker Enterprise Engine is going to be included with Windows Server 2016, the enterprise version with enterprise support. So that's really a fantastic continuation of that work. Now, one of the interesting things about container is at the very end of the day, it's still relatively new. Okay, when I talk to people, I find very few people that are doing much beyond kicking the tires. Every so often I'll run into someone who's got, a little small section of apps that they're writing, but it's still something that's very new to a lot of people. And so when people ask me, Jeff, what are the scenarios for containers? Can you give me a full list of what those are? Quite honestly, we're still trying to figure those out. And when I mean we, I mean the entire industry. There's a lot of interesting challenges that we're still trying to figure out with containers. Because as you saw, he can start it and stop them just like that. If I need 5 or 10 of these, he literally copies that command, gives it a different IP address. Boom, I got 10 of these. So they can be very ephemeral. They can come and go very quickly. Well, how do you deal with security? How do you deal with identity? There's interesting new challenges with that. So with that, I wanted to invite Amir Jirbi, the CTO and co-founder of Aqua, to actually give a quick demo of some of the work that they're doing with the Aqua Container Security Platform. Thank you, Amir.
Thank you very much. So hi, everyone. My name is Amir Jirbi, the CTO and co-founder of Aqua. At Aqua, we specialize in container security. And we just announced our support for Windows 2016 containers. And I want to show you a small demo on what we did. Maybe before the demo, my 4 takeaways for the container security. So how do you secure your containerized applications? So first of all, you need to make sure that you don't run any unauthorized images in your environment, right? So think about the situation. You have hundreds and thousands of images in Docker Hub. You don't want all those images to be in your production environment. You need the gates and controls for which images get into your production. I will show you how to do that with Aqua. Second of all, least privileges. You don't want an IIS image to be just able to connect to anywhere in the network. You want to limit your images or your containers to be able to connect to their peer applications. Third of all is least privileges for your processes and files. Each container only has a subset of processes it needs access to. And the last thing is least privileges for your admin users. You want to control which user has access to the containers. Let me show you how Aqua deals with those concepts. Yeah, connected. So this is the Aqua Management Console. It's a container by itself. I just deployed it. And as you can see, when you deploy Aqua, we start by scanning your environment. So we scan all of your images in the environment. You can see Windows and Linux images. And the nice thing about that is once we identify an image with vulnerabilities, in this case, I just entered, I've put here an image with some high severity vulnerabilities, we can decide that this image will not get into your production environment. You see that it's marked as disallowed. The outcome of that is if ops will try running this image in production, they won't be able to do that because of Aqua Agent installed on this Windows 2016 machine. Let me show you how it looks like. So if I will do Docker images, I just see what images out there, and Docker run Microsoft IIS. Docker run Microsoft. So you see, I tried running an image, which is disallowed by Aqua, and I cannot do that. I cannot run a disallowed image. Of course, if you will look also at the Aqua Management Console, you will see that, hey, there is a new log event being recorded. Someone just tried running a disallowed image. You cannot do that. So this is the first thing, making sure only allowed software, only allowed containerized applications gets into production. Let's talk about the second thing, network segmentation. So like I said, least privileges is very important. If you deploy your IIS, you only want this IIS to be able to communicate with SQL Server, right? So in order for this to happen, in Aqua, we have a concept of applications. You can define a web application, for example. And in this web application, you can see that there is outbound and inbound network connections. So I specify that members of the web applications will only be able to communicate with this IP and this port, my SQL Server, basically. Let's see what it means. It means that if I will now run an IIS container, the command is very long, so I have a batch file here. So you see it's a Docker run. And then you see this environment variable, Aqua app. I've just told the container, hey, you are now a member of the web application. So I'm running IIS. That's a regular IIS. And let's see what happens if this IIS tries to do something malicious. So I will execute into this container, Docker. I'm inside the container right now. And if I will try accessing a malicious site, like I will try downloading an exploit kit, I won't be able to do that. You see, I got access denied. I tried connecting to the internet from an IIS, no outbound network connection to there. You can only connect to the SQL Server. And of course, if, again, you will go to the Aqua Command Center, you will see that there is an audit trail saying, hey, this container just trying connecting to the internet. That's something bad is happening there, right? Very important visibility and least privileges. Last thing about least privileges is, like I said, you want to control what are the processes inside of this IIS. This is a regular Windows container. It has hundreds of binaries inside there. There is a binary to restart the machine. There is a binary to log off. There is a lot inside. And you really want to control what this IIS can do. So in Aqua, what we did, you see these runtime profiles. You can define a runtime profile for your application, for your containerized application. Basically, a runtime profile defines, it's a whitelist approach. It defines what files are allowed. It defines what processors are allowed for an IIS to run. You see, it's a very long list. You don't need to manually type this list. We have recorders that record the activity and then generates those whitelist approaches. And the outcome of that, the outcome of those whitelists, if right now I'm inside this IIS container, it might be running on-prem, it might be running in the cloud, doesn't matter. And I will try doing something like log off. Cannot do that, access denied. I will try doing PowerShell -C, restart computer. I cannot do that. Again, it's a shrink wrap approach. Aqua identified what's the whitelist for this IIS, and it will only allow running the processes inside of this IIS. If you will look at the audit logs, you will see again, hey, somebody just tried doing log off inside of a container. That's bad. Go and look what happens inside. Last thing, so I've also mentioned least privileges for your users. So think about a situation where you have an admin, Alice, and you don't want Alice to be able to stop containers, start containers, modify them. You just want Alice to have access to log file inside of containers. So what will usually happen is that you cannot really segregate permissions between users, but with Aqua you can. So right now I'm logged in as a user called Alice. You can see I'm logged into the same machine, and there's an Active Directory user called Alice, and Alice can look. She can do Docker PS, meaning she can look at all of the running containers on the machine. But if she will try stopping a container, she won't be able to do that. The reason is that there is a role-based access control system inside of Aqua that you can use in order to provide permissions to your users. But on the other hand, Alice can do Docker logs, and she can look at what's inside, what are the log files of the container. And this is, again, centrally managed. Very simply, we have some out-of-the-box policies. You see we have an auditor role. I just entitled Alice to be an auditor. So just to summarize, 4 takeaways from this session. Make sure you only allow running your images which are approved. least privileges for the network, least privileges for processes and files, and last thing is admins. Provide them with the appropriate roles. Any questions? Look out for people with the Aqua shirts.
Great.
Okay.
Awesome.
Thanks
Thank
so
you,
much.
Amir. Great job. Great job.
Oops. You're an RDP.
Thank you. Fantastic. Thank you very much. Love to see what's going on here. We're going to keep a close eye on what's happening in container world. Thank you, Amir. Lastly, Azure Container Service. So one of the things we want to point out is, with containers, you've seen Docker, you've seen Aqua. We're very much plugging into all different types of orchestration engines. If there's anything I want to point out with Windows Server containers and Hyper-V containers, is we want to make sure that the tools out there just work. Hyper-V containers, Windows Server containers, you want to use Docker? Great. You want to use Mesos? Great. You want to use Swarm? Fantastic. By the way, the Azure Container Service is up there. Using standard Docker tooling and API support. We have Linux and Windows Server containers up there. Linux containers have actually been up there for some time. Windows Server containers have gone up, and you're going to see more and more development, again, with Azure and Azure Stack so that we can have a great, consistent container story. And then finally, I would ask you to if you're interested, want to know how a customer has actually deployed containers in production. This was actually in the keynote with Scott, but Tyco is doing some really interesting things with containers, and really they wanted to actually reduce costs for hosting and supporting DevOps. They deployed Server 2016 Core with containers, and they've been doing exactly what we've been talking about, which is they've taken existing .NET applications that they already had. These weren't brand new ones, these are ones that they already had. They brought those that were running in virtual machines before and brought those into Windows Server containers. They are actually able to take advantage of the DevOps. There's actually additional efficiencies you get with containers. For example, memory density is dramatically different. I'll give you one quick example. Let's suppose you need to fire up 10 IIS servers, and you actually put them in 10 different VMs running Windows Server 2016. Assume each one of them used like a gig of memory. Well, if I wanted to fire up 10 containers running IIS, the first server probably runs, it's going to run a gig, but each one of those additional containers is maybe another 10, 20 megabytes. So all of a sudden I've scaled out, I'm running 10 web servers, and I'm using a fraction of the memory that I would have had using traditional VMs. So containers also do provide other efficiencies that we haven't even gotten into today. And of course, this takes us into what you're going to run in that container. Jeffrey?
Yeah, okay. So Nano Server is the target for all new application development. Okay, so Windows Server 2016, we have 3 deployment options. First is server with a GUI. Okay, server in a desktop. This is focused in on small businesses, a machine that you're going to put the server on. You're going to walk up to it with the touch screen and say, "Hello Cortana, log me in." Right. So small businesses and remote desktop scenarios. Those are the scenarios for server in a desktop. Then we have Server Core. Server Core is focused in on running our heritage data center applications. And then we have Nano Server. Nano Server is the focus for new, modern server applications. Now, just to get this in focus, right? So when we did Server Core, we took server and we started taking stuff away. Nano Server took the opposite approach. What was the minimal viable product? What was the smallest part I could start with? And then we started adding things from there. So you have components on top of that. The results are staggering, right? So just take a look. Setup time for Server Core, about 300 seconds. Nano Server, 35 seconds, almost 1/10, right?
And
Boot
that's
time?
setup time with a machine with nothing on it, like a completely blank system. Setup time to, I've just booted up into Nano, 35 seconds flat.
Yeah, you know, I got to tell you, you're going to hear these numbers and you're going to like, and you got to experience it. You got to experience it. And when you experience it, like those numbers just come, they hit you like a train, like, whoa, wait a second. Like boot time, 85 seconds, down to 9 seconds, 9-second boot time. And I believe this is like, I've seen VMs on a drive, on a system with SSD drives, the VMs start in like 2.5 seconds. I mean, cold boot, it's just phenomenal. Okay, disk space goes from about 5.4 gigabytes down to 460 megabytes. This is just a fantastic rockin' system.
I'm sorry, Jeffrey, what was that word you used? Was that megabytes?
Megabytes, right.
Megabytes.
460 megabytes.
Okay.
Just crazy small.
For the younger folks in the audience, a megabyte is smaller than a gigabyte because I haven't used that word in a long time for an operating system. So
That's good. I like that. I'm going to steal that. Okay, so we are focused in now, just as with Server Core. You know, this is not for everybody. We are focusing in on 2 specific scenarios, and then we will grow that over time, right? Eventually, Nano Server will be the foundation for all Windows Server scenarios. But in Windows Server 2016, there are 2. The first is, this is a target for fabrics, right? Hyper-converged and storage fabrics. You put it on the physical machine to run the hypervisor, put it on the physical machine to run storage, right? It's small footprint, it's secure, fast boot time, just optimal for those environments. And the next is, it's ideal for next generation applications. You know, your container host is perfect for, Nano Server is perfect for your containers. Now, how do you remotely manage Nano Server? So you saw that login configuration. There is no local login for Nano Server. What you saw was an emergency management console. Nano Server is, by definition, managed remotely. Now, this is where people get a little hung up. Like, you should not think of Nano Server in the context of a modern application as the equivalent of the old server, right? In the old server, you put everything in one box and you manage that box and you train it. Here, you're going to have lots of them, right? So it is not a model where you want to be spending a lot of time keeping any one thing up and running. Okay, you want to manage remotely. You want to be able to manage through automation. You'll also want to investigate a model called immutable infrastructure, which says, once I deploy it, I never change it. I throw it away, make any changes back in the build lab, recreate one, and redeploy it. Okay, so what I'm saying here is that the modern application model is a new model. And we've got technologies that support that new model, but it is a new model. Now, at various times, you will want to go manage an individual machine, whether it's because, hey, I'm put it on a physical box and I'm not using that model. I'm managing a Hyper-V server or a storage server, or I'd like to log into one and manage it, to diagnose it. There, we've got great remote management tools, right? Server Manager works against this, Hyper-V Manager, Failover Cluster, Perfmon, EventMon, all that good stuff. There is a new version of PowerShell called PowerShell Core. Nano Server supports, Server Core supports the full .NET framework. Nano Server supports the .NET Core framework, okay? In order for PowerShell to work in this environment, we had to refactor it, and there's a new version called PowerShell Core. That was the work, the heavy lifting, that enabled PowerShell to then be available on Linux and Mac OS. So, pretty great stuff. And of course, we now have a new server management tools. These server management tools are web-based GUIs running in Azure to manage your servers anywhere. Okay, now this works great with Nano Server, but it will also work with Server Core and Server with the GUI, and to some degree it'll work down level. Some of the functions require new providers, WMI providers, that are only available in Windows Server 2016, but most of the functions are available down level. So great remote management, but it is a different model. You are going to have to learn the new model. Okay, people, as we've been deploying this through our TPs, technical previews, people have had some challenges building the Nano Server images. We now have a GUI-based Nano Server image. It is a 2-pass image builder. The first one, you can go create a new Nano Server image, and then alternatively, after you're done with that, you can create a USB, a bootable USB media from that image that you created in the first pass. Okay? It's a GUI, it's a wizard. You walk through, select the things that you want to put into that image, and then ultimately create it. And you'll see we also are providing the PowerShell command line to do this operation again. Okay. So born in the cloud applications are really this new modern model, right? Microservices, composable, allowing each element to scale, interoperate through protocols. And And this really allows your teams to go fast and to work well between your developers and your operators. What you'll see is, and in fact on Thursday I've got an entire session that talks about how we made fundamental architectural changes to Windows Server to better support DevOps. We'll talk a little bit about this today, but if you want more details, that'll come on Thursday. So again, this idea of the monolithic application, where you put all the components in together in one environment. The microservices is where you can put them in different environments, okay? And again, the nice thing about this is once you have these components in different environments, they can have their own life cycle. That then brings up the question, who manages the life cycle? And as Jeff mentioned, there are numerous technologies out there to do that. We are investing in this. We are investing in Azure Service Fabric. Azure Service Fabric is an amazing technology. Our Azure Cloud uses it quite extensively. Intune uses it. Azure SQL uses it. We have some of our largest services using Azure Service Fabric.
Well, an important point is Azure Service Fabric is how we write our applications on Azure. SQLDB is a perfect example. People have asked us, hey, if I wanted to write an application, like a broad scalable application like SQLDB for Azure, how could I do that? Azure Service Fabric. And one thing to note is, and the name can be a little confusing because it's called Azure Service Fabric, so people think it only runs on Azure. No, it can actually run anywhere. It can run on Windows, it can run in AWS, it can run in Azure, it can run in Linux, it can run in VMware, it can run anywhere. Correct. The reason why the name Azure is in front is because that's literally what we use to build our own native applications on Azure.
Right, and so it gives you these great properties of scalability, availability. So think of it as like failover cluster plus, plus, plus. So it can decide, you can go and say, hey, for this component, I'd like to scale it up to 5 things. Now I'd like to do it to 10. Now I'd like to go back to 5. It will deploy that. It has a leader election model. It even has a distributed persistent key value pair, which if you write distributed systems, you'll find that this is one of your best friends. So this is some great enabling technology, and what it does is allows your developers to focus in on the feature functions and less on the details of how to keep those feature functions scalable, available, how to upgrade them from one version to another. This defines how you do all that. Really amazing technology. Oh, there you go. Developers focus on the feature, not the infrastructure. The automation gives you scale and reliability. And again, you can run this anywhere. Any cloud, you can run it in VMs if you want, run it on physical hosts if you want. You can even run it in Linux. Ultimately, what you see here is a trend, right? Industry trend strongly expressed in Windows Server 2016. And that trend is what I call the just enough agile technologies, right? And so really what you want to think of this is, in the old days, you'd buy a server, spend a lot of money on this thing, and that was the focus of all your attention, right? That was the thing you purchased, those are the people you hired to manage it, and then what? Well, on that server, you'd put applications, put one application, put another application, put another application. But the mindset was all about the server. Well, we believe that that's shifting, and that the center of the world is now the application, okay? And that everything serves the application. So in just enough operating system, Nano Server, you only have enough of the operating system to support the application. Nano Server starts at 480 megabytes. If it turns out you need 3 gigabytes worth of components to run your application, that's fine. But you're bringing them on because your application needs them. It is not the case that you have these 3 gigabytes worth of components, and if your application doesn't have them, you still have them. Because each of these components has resource consumption, servicing footprint, security footprint. If you use them, it's worth it. If you're not using them, it's not worth it. So that's the thing. The model's getting flipped on its head. You start with the application and bring things in. That's what container is, right? A container is a way of capturing, here's my application, and here's everything that application needs, and I put it together as one big glop, and I move that glop around, Okay, the focus is on the application. .NET Core, same model. They did the same refactoring that Windows Server did. Started very smallest component possible, and then you bring in the elements and only the elements that your applications needs. We're doing this with operations as well, okay? With JIT and JIA, it's a way to say you have just enough administration access to do the operations that you need for the application. And the Nano Server and Service Fabric are the same principle, but now applied to the host itself, the underlying fabric. Run Nano Server on the hypervisor, because the reality is when you're just managing VMs or just providing an environment for VMs, you don't need a lot, and you don't want a lot because it consumes resources, it has to be patched, it exposes a security footprint. So, as I mentioned, Windows Server 2016 has been architected to make applications great for DevOps. Now, I want to be clear here, it's architected to make applications great for DevOps. Applications need to play, okay? So there's a number of things. You're going to build your applications differently on Windows Server 2016. Lots of different areas, right? So here were some of the roadblocks that we had, right? The area of installer. We now have a very good installer, a well-defined installer called Windows Server App Installer, WSA. There was really no good story around packaging and repository management. Now we have that. We call that PowerShell package management. In the past, we didn't have a particularly good story around configuration management. We started to fix that a release ago with the introduction of desired state configuration. That was a major investment in this release of the operating system, and now that is in very good shape. Operational testing. Operational testing is the idea of being able to validate that your operations are working. And we've really never had that concept much in the OS. And now it's a formal part of that with something, again, called PowerShell Operation Validation. And then the secure operations, I mentioned, supported by PowerShell Just Enough Admin. So first a word around MSI, right? MSI, anybody using MSI? Right, I want that thing to die. Okay, that thing is just, so here's the problem, right? Started off good, architect thought a good idea, blah, blah, blah. At some point they said, yeah, but what about? And the problem was, every now and again, to be a good architect, sometimes you just gotta be a butthead. And when they came to that person and they said, hey, what about? He should have been a butthead and said, change the way you're thinking about it, change the way you're doing things. We're not gonna have custom actions. But instead, he allowed custom actions in, and that was the portal to hell, right? And the reason why it's the portal to hell is now I can't do offline operations. I can't deploy offline, I can't service offline. I don't really know what's happened, right? Declarative, I know everything, and then, I don't know, I run arbitrary code. Who the heck knows what happened?
Tell us how you really feel, Jeffrey.
It's a disaster, okay?
Don't mix words.
Okay, I won't mix words. WSA, by the way, so this was my slide. I'm not making fun of marketing slides, okay? Nice cat, so cute. Anyway, so WSA, it is a purely declarative. There are no imperative actions. This is based upon the client installer and then extended for server scenarios, things like COM objects, WMI extensions, perf counters, no custom actions. Now this enables, but we're not taking advantage of it yet, it enables us, it paves the path for us to do offline installation, offline servicing, just everything you've all wanted and said, hey Microsoft, what the heck? How come you can't deliver us to this for us? Now we will be able to do that. And you get a cute kitten. Now in terms of package management, here's the gotcha. The gotcha is that there are lots of package management systems. So off to the right? There's WordPress, there's Node.js, they got stuff, there's NuGet, there's container galleries, there's Docker. There's a world of mess, right? Well, what we wanted to do is we wanted to give you a common experience, right? Each one of these things have different APIs, different CLIs, different semantics, it's a horrible world. And so we architected an experience in between, right? A way that you have an end user experience that gives you a comprehensive way to discover things, install and uninstall them, get an inventory of what you want, And how do you get that consistent experience? It's through these providers, right? So we've got providers that then consume the packages from various sources. Ultimately, you're left with a world like this. Find a package, searches for a package, save a package, takes it from the repository, brings it down, puts it on the disk, install the package. You can install the package from the repository or from the thing you installed on the disk. Get a package, show me an inventory of everything that I have, and uninstall the package. Pretty nice world. Pretty nice world. And you'll be able to do this across the wide variety of components. So, pretty good stuff. Desired state configuration. Desired state configuration, we have a purely declarative way. It's actually a mixture of imperative and declarative, but ultimately what you're doing is you're declaring how you want the system to be. Very simple expression. You see here, I want a Windows feature, I want it to be present, I want this pulse over, here are the attributes I want, and then you say, make it so, and the system will make it so. And it will make it so, and it'll tell you if there's any deviations. If it detects a deviation, it will report on that, and optionally, you can have it auto-correct it. So it will detect and repair configuration drift. Okay, this is a platform play. It is a platform play, so if you have stuff to be managed, you plug into this. If you want to consume it and do desired state configuration, you can do your own scripting with PowerShell, or you can buy one of many of the great configuration management products out there, like Chef, Puppet, Azure Automation, that will consume this as a platform. So there's this problem around operational validation testing, right? So sometimes things can be configured properly, but then just not operate, okay? Now the computing equivalent of this is, imagine a perfectly configured server that doesn't have the Ethernet plugged in, right? You look and you say, oh, everything looks fine, except it's not operational, okay? So we're trying to address that. By the way, another way to tee that up is, quick question. Patch Tuesday? You just patched all your servers? When do you get to go home? When do you get to go home? Who knows, right? What a crappy world that is. Who knows? I don't know. I changed everything, and I guess I wait around by the phone, and after some point, if it doesn't call, I go home. But I still like, I don't know, honey, maybe we better not go out tonight because I might get the call might be. What a crummy world that is, right? So imagine instead you said, hey, before I apply these changes, I'm going to run operational validation tests. I'm going to go test all my components to see if they're operating properly. By the way, if they're not, maybe you don't want to go change anything. Maybe you want to go fix that first. But you go and you check and everything's running. And then you apply the patch and you go and check if everything's running. Hey, can I still send mail? Can I still connect to SQL? Can I still insert a column into a table? And if everything's working, then you can go home and you feel pretty confident. So that's what we're trying to engineer here. And so we do this through PowerShell. It's an extension to the unit test frameworks within PowerShell. And you see it's some very simple stuff, right? Describe a scenario, you say what it does, you run some PowerShell, and then you do a series of expressions on the results. And then you get a world like this. You invoke that test, and it says, look at that. The SQL service should be running. It tells you how long. The SQL service agent should be running. Should be listening on this port. Should be able to query information. So again, you made a change, and all of a sudden you run this, and it says all those things are working, the times look about right. Hey, go home. Go out to dinner with your wife or husband, your spouse.
Thank you, Jeffrey. So one thing I wanted to make sure I put in here was, and it's a little going to go slightly off the beaten trail of app conversation for just a moment, but it is important. I wanted people to understand this because I've had a few questions about this. Hey, Jeff, with all the things going on with servicing, especially in client, is Windows Server 2016 servicing changing? And so I wanted to be super clear as to what is actually happening. So first of all, what you've just seen is we've seen Nano Server, we've seen Server Core, and of course there's Full Server. So if we look at the two that we've always had, or we've had since 2008, Full Server and Server Core, those are going to stay exactly the same. 5 + 5 years of servicing, security and quality fixes only. Nothing has changed. We want to make sure that if you're used to the way you're consuming Windows Server, there's no change in that model at all whatsoever. The one that is different, it's not a change because it's never existed before, is Nano Server. NanoServer is current branch for business only. And the reason why is actually very, very, very logical. It's brand new. And we are very much in a listening phase. We want to understand what you need, what's important. Are there things we need to add? Are there things we need to change? Is there something that's critical that's a blocker for you for deploying or creating a new application? And so we wanted to make sure that we had that ability to make those changes very quickly. So NanoServer is CBB only, okay? So just keep that in mind. It doesn't change quality, features, and functionality. And installation is still under the control of administrators. I want to be very clear about this. We're not forcing down any upgrades. Nothing has changed. We're in the world of server. In the world of server, you guys are in control. It's very different than things in the client world. So think about what we've talked about today, the modern application platform. We've talked about the ability to take your existing applications with literally no change and say, let's just put them in Server 2016. Let's give you a more secure application experience. We've talked and actually shown and demonstrated taking existing applications and bringing those into the world of containers so that you can now start to embrace a DevOps model and start to think about what these new architectures look like. And then there's the third model of, hey, now we start to write cloud-native applications. Now we're going to start thinking about actually re-architecting our applications to use microservices to take advantages of the things, the benefits of cloud. So next steps, first of all, of course, if you haven't downloaded the bits, we have the eval bits so people can get their hands on. Start playing with containers. And as you saw with Patrick's demo, Hyper-V containers are there in Windows 10 Anniversary Update right now. That was actually shipped in Windows 10 Anniversary Update. So you actually have Hyper-V containers, which means you could actually create containers right now and deploy them on Windows Server 2016 eval bits. And you could actually deploy them as both Server 2016 containers or Hyper-V containers. Because again, they're exactly the same. It's a runtime option. So download the bits. Make sure you stop by the booth. Come chat with us. We'd be happy to talk to you and understand what's more, answer any questions you have. And by the way, don't forget to check out the HoloLens and NanoMan at our booth. It's really cool. We got a HoloLens over there, and we actually have a NanoMan app you can actually play with.
That's awesome.
So with that, I just want to say thank you guys very much. Jeffrey?
Yeah, so hope you have a great Ignite. If you're interested in Azure Stack, you can race along with me all the way across to building C1, where Mark Russinovich and I will be talking about Azure Stack, but I do got to race.
Yes.
So
put your track shoes on. And if you're interested in more about Windows Server 2016, I'm going to go deeper dive on that, and that's actually just downstairs one floor. Thank you guys very much, and enjoy the rest of the conference.